student, welcome to all of you in next physics lecture. This is the video number 25. Myself, Rajesh Lagar, physics teacher, and we have to see here the chapter number 3, kinetic theory of gases and radiation. Now we have to see the next very important topic, that is the derivation of power, the pressure exerted by the given mass of gas, that is the P is equal to 1/3 rho into V square. For derive this expression for the pressure, we can consider here a diagram for a cube, and a gas is enclosed in that cube, having the each side of length L. We have to take here the capital L. Now the area of each face is given by A is equal to L square. Also, volume of the cube is nothing but L cube, or we can also write this L cube instead of L cube, A, that is the area, into L. Same, L cube or A into L. Now we have to consider here, let N be the total number of the gas molecules, that is the capital N, total number of the gas molecules which are included inside the cube, and m is the small m, is the mass of each gas molecules, and therefore total mass of the gas enclosed in a cube is given by, that is the capital M is equal to N into M. Capital M is the total mass, N is the number of gas molecules, and M is the mass of the each gas molecule. Therefore total mass M is equal to N into small m. Now rho is the density of the gas molecules, and which is given by rho, that is the density, mass per unit volume. Rho is equal to m by v. Now our derivations, we have to substitute here m by v. Instead of m by v, we have to take here rho. Also this m, nm and L cube, we have to take here the v. Therefore rho is equal to mass per unit volume, that is the nm upon L cube. Then for our sake of convenience, for our sake of simplicity, consider the three intersecting edges of the cube, and which are rectangular coordinates axis, x, y and z axis. We can assume here the average number of the gas molecules, which are the n by 3. We have to take here, suppose the number of gas molecules 1, 2, 3 dot dot n, but here for our assuming the average number of the gas molecules, which are the n by 3. Why you have to take here the number of gas molecules n by 3? Because these gas molecules which are distributed along the x, y, z, these three coordinates rectangular axis x, y, z, which are the gas is moving along with these three parallel axes, and so that the number of gas molecules, that is the average number of the gas molecules, we have to take in that derivation, instead of n, we have to take n by 3, because the gas is distributed along the three coordinates rectangular axis x, y, z. Therefore we have to, for sake of convenience, we have to take here the average gas molecules n by 3 molecules. Now we have to consider here the velocities of that gas molecules, just like v1, v2, v3 dot dot dot. Not only we have to take here vn, but instead of vn we have to write here vn by 3, because we have to, for sake of simplicity, the number of gas molecules are n by 3, so that v1, v2, v3 dot 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 vn, instead of vn we can write vn by 3. You remember that terms n by 3, why you have to write this n by 3 molecules. Now consider the molecules of mass m and the velocity v1. We have to consider the single gas molecules having the mass m and the velocity v1, and these gas molecules which can be the collide on the surface S, then its initial momentum, mass m, and the velocity v1, then its initial momentum is nothing but mv1. But this is the gas molecules, and these gas molecules when collide on the surface S, it should be rebound from the surface S and again moves with the same velocity but in opposite direction. Therefore its velocity is minus v1. Mass is the same but the velocity is in opposite direction, so that it is minus v1. And therefore the final momentum is equal to minus mv1. You have to remember that the initial momentum is mv1 and final momentum is minus mv1 because the gas is collide on the surface S, rebound with the same velocity but in opposite direction, so that its final momentum is minus mv1. Now we can find out the change in momentum. Therefore the change in momentum is nothing but what? Final momentum minus initial momentum. Change in momentum is equal to final momentum minus its initial momentum. Substituting these two values, then we get minus mv1, that is the final momentum. Initial momentum, here minus sign, therefore we can write minus twice mv1. This is the change in momentum, minus twice mv1. Because the momentum is nothing but what? It is the product of mass and velocity. Therefore we have to take here the mv1. Mass is the constant and the velocity is the varies. Therefore initial momentum mv1, final momentum minus mv1, change in momentum minus twice mv1. But according to the law of conservation of momentum, there is no loss of momentum. According to the law of conservation of momentum, there is no loss of momentum. Therefore we can write here, according to this law of conservation of momentum, change in momentum is equal to, instead of minus we can write here plus twice mv1, because according to this law there is no loss. Therefore we can write, instead of minus sign we can take here the plus sign, and change in momentum is equal to plus twice mv1. This is very important. You have to remember the change in momentum, instead of minus we have to take here the plus twice mv1 according to the law of conservation of momentum. Now due to the collision the velocity is reverse and returns with the surface S. In one collision the number of gas molecules collide with the surface S, which is equivalent to the v1 upon twice L. Number of collision per second, which is given by v1, that is the velocity for the first molecules, and total distance L plus L, that is the twice L. Therefore velocity v1 upon twice L, this is the number of collision per second, and we have to find out this nothing but the change in momentum in one collision, that is the twice mv1. Therefore we can find out the change in momentum at the surface S. Therefore we can find out here the change in momentum at the surface S, and which is given by the change in momentum in one collision into number of collision per second. This formula is the very important. Next we have to derive this formula for the pressure. The change in momentum at the surface S is equal to the change in momentum in one collision into number of collision per second. Substituting this value we can find out this change in momentum in one collision, that is the twice mv1, and number of collision per second, that is nothing but the v1 upon twice L. Therefore the change in momentum at the surface S is equal to twice mv1 into v1 upon twice L. Two get cancelled, and m v1 into v1 square and upon this L. Therefore change in momentum at the surface S is equal to m v1 square upon L. Now we have to find out the total change in momentum at the surface. We have to find out the change in momentum for the one molecules, single molecules. Now we have to find out the total change in momentum at the surface S, which is equivalent to for the number of gas molecules, and this is nothing but what? That is equal to m v1 square upon L plus m v2 square upon L plus dot dot m vn by 3 square upon L. Again you have to doubt that how you can write the n by 3. Then again you remember that this, instead of n, we have to take here the n by 3, because these gas molecules are distributed along the 3 coordinates rectangular axis x, y, z. Therefore we have to take instead of n by 3. Then we have to write here m v1 square by L plus m v2 square by L plus dot 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 m vn by 3 square upon L. Then again, according to the Newton's second law of motion, the rate of change of momentum is equivalent to the applied force, and therefore this change in momentum at the surface, instead of this we can take the F, because of this Newton's second law of motion. Therefore F is equal to this. Then we have to take the common m by L, and various terms are remaining in this bracket. That is, F is equal to, according to the Newton's second law, total change in momentum is nothing but the applied force. Therefore we have to write here F instead of this total change in momentum. F is equal to m by L, this is the common, and remaining terms, various terms in the bracket, v1 square plus v2 square plus dot 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 vn by 3 square. Then we have to consider the mean square velocity. We have to separately explain this mean velocity, mean square velocity, and root mean square velocity, that is the RMS velocity. Therefore we can write here mean square velocity. Mean square velocity what means what? v1 square plus v2 square plus dot 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 vn by 3 square upon n by 3. Because we have to substituting the values of this bracket, v1 square v2 square plus dot 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 vn by 3 square. Instead of this bracket we can write n by 3 into v square bar, and this v square bar is nothing but this is the mean square velocity. Therefore we can write the definition of this mean square velocity. V square bar, that is the mean square velocity, is equal to v1 square plus v2 square plus dot 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 vn by 3 square upon n by 3. This is the mean square velocity. But we have to write the values of this bracket, v1 square v2 square dot dot vn by 3 square. Therefore v1 square v2 square dot dot vn by 3 square is as it is, and this denominator term n by 3 is take this side. Therefore this, in this bracket we can write n by 3 v square bar. See here, this is the bracket here, v1 square v2 square dot dot vn by 3 square, and take this denominator term on either side, n by 3 into v square bar, and substituting this value of this bracket we can write n by 3 v square bar. This is the mean square velocity. Therefore F is equal to m by L as it is, and instead of this bracket v1 square v2 square dot dot vn by 3 square, we can write simply n by 3 v square bar. Then substituting this, F is equal to m by L instead of this bracket n by 3 v square bar. This is the mean square velocity. Therefore rearrange this, take this 1/3 this side, F is equal to 1/3 nm upon this L and into v square bar. We can rearrange in the terms. F is equal to 1/3 nm upon L into v square bar. Again we have to find out the expression for the pressure, and therefore by definition of pressure, this pressure is nothing but the force per unit area. This derivation is lengthy, you can remember that point. Law of conservation of momentum, also Newton's second law, and now the definition of the pressure. By definition of the pressure we can write here P is nothing but force per unit area. Therefore P is equal to F upon A. Substituting instead of F, we can find here F is equal to 1/3 nm upon L into v square bar. Therefore P is equal to 1/3 as it is, nm upon L into v square bar, and divided by A. A is there, and this area is nothing but what? That is the L square. Initially we have to write here the area of the each surface A is equal to L square, and this L square into L, this is nothing but the L cube. See here, P is equal to 1/3 nm as it is, v square bar as it is, L into area is nothing but what? L square. L square into L, that is the L cube. Therefore, P is equal to 1/3 Nm upon L cube and into V square bar. Now, we have to see here this, if the V is the RMS velocity, that is the root mean square velocity. This V is the RMS velocity, where to V square bar is nothing but the mean square velocity, and V is the, simply V is nothing but the RMS. RMS is what? Root mean square velocity. Root mean square velocity, and which is given by V is equal to, this full form RMS velocity, we can explain this, V is equal to under root V square bar. Okay, V is equal to RMS velocity, and which is given by root mean square velocity, that means this mean square velocity, root mean square velocity, that is the V is equal to under root V square bar. Then squaring on the both side, therefore instead of V we can write here V square, and squaring on this root, root is removed, therefore V square is equal to V square bar. Now instead of this V square bar, that means square velocity, we can write simply V square. Therefore P is equal to 1/3 Nm upon L cube, and instead of this mean square velocity, we can write the RMS velocity square, that is the V square. Now initially we have to see here this Nm is equal to capital M, write this capital M, Nm is equal to M. Then this L cube, instead of L cube we can write this is the volume of the cube, L cube, instead of L cube we can write V, and instead of Nm we can write capital M. Substituting this, P is equal to 1/3 as it is, Nm we can write capital M, L cube, that is the volume, V, and into V square. Again this M by V is nothing but what? That is the density, rho, mass per its volume. Therefore instead of M by V we can write the rho, P is equal to 1/3 rho into V square. P is equal to 1/3 rho V square is the expression for the pressure exerted by the given mass of gas on the basis of kinetic theory. This is the very important. The numericals also solve on this expression for the pressure, and you remember this, all this point. I can again explain in short how it can be the, you have to write this in your exam. First you have to draw the diagram cube, then you have to note it here L, surface S, velocity V1 minus velocity V1. Then gas is enclosed in that cube, A is the L square, V is the L cube, rho is the mass per unit volume, Nm upon L cube. Single gas molecules moves with the velocity V1, reverse with the velocity minus V1. Change in momentum, that is the minus twice mv1. According to the law of conservation of momentum, no loss of momentum, plus twice mv1. Writing this formula, we can write twice mv1 into v1 upon twice L2 to get cancelled, and mv1 square upon L. But this is the single gas molecules. We have to find out the total change in momentum at the surface M. Therefore mv1 square by L, mv2 square by L, mv3 square by L, dot dot dot, mvn by 3 square upon L. Then according to the Newton's second law, this change in momentum is nothing but what? Applied force, and therefore we can, instead of this change in momentum, we can write F. F is equal to m by L, v1 square, v2 square, dot dot, vn by 3 square. Then we have to consider here, we have to turn here the mean square velocity, and the mean, you know that this mean square velocity, v square bar is equal to v1 square, v2 square, dot dot, vn by 3 square upon n by 3. Take the cross multiplication here, and instead of bracket we can write n by 3 into v square. Substituting this, m by n by 3 into v square bar. Then rearranging 1/3 nm by L v square bar. Then the pressure, now remember this definition of pressure, P is equal to F by, substituting F 1/3 nm by L into v square bar upon A. A is here, A is nothing but the L square into L, L cube. Then again this we have to consider here V, simply V, RMS velocity, that is root mean square velocity, and which is given by V is equal to under root v square bar, and squaring on both sides, v square bar is equal to v square. This is the v square, and this square root is removed after squaring. Therefore, instead of V square bar, we can write simply V square. P is equal to 1/3 Nm by L cube into V square. Nm capital M, L cube V, and M by V is nothing but rho. Therefore, P is equal to 1/3 rho V square is the pressure exerted by the given mass of gas on the basis of kinetic theory. Okay, understand? Okay, we have to stop here. Thank you.